Hello guys and welcome back to my channel. File again. We are learning CCSA objects and concepts. In chapter 1 we have seen what is checkpoint firewall overview, the checkpoint firewall secure management architecture, checkpoint firewall core components and the three-tier architecture, OSLM model and where the checkpoint firewall fits in, mechanism for controlling network traffic like packet filtering, stateful inspection, application intelligence. Now, on this video, we are going to continue the chapter 2 on a further discussion. So, we'll be learning checkpoint firewall stateful inspection architecture, stateful stateful inspection architecture. Then we'll learn deployment of checkpoint firewalls, components, gateways, and their consideration. And we'll see what are the high availability solutions available. So let's start without wasting further time. Let me clear the screen. Sorry for that. Let's begin with checkpoint stateful inspection architecture. To understand more on that, I just wanted to draw a flowchart where how the packet is, communicate. So this is the NIC from where the packet is entered into the firewall. This is the number one step where new connection detects. If we detect a new connection, then what happens? Here packet matched against rules base, and based on this decision packet is either allowed or denied. This is what happens generally with the packet filtering firewall. Now, what happens when the stateful inspection inline? So when packet enters from your NIC, usually the packet has these parameters like your source IP, destination IP, source port, destination port, and protocol. So these fields checks against packet. If there is a new connection, these fields store into the internal state table, and the packet is goes for further processing like your rule base, etc. But if this connection record is already existed from the previous packets, then further processing from here what happens based on these decisions, I mean these fields captures which are stored into the state table, the packet is allowed or denied. This is what happens in a stateful inspection. So now let's see some theoretical part. The security gateway integrate both the network layer and basically we are talking about the security gateway stateful inspection architecture. I just wanted to write it here so we will be on the sync. Security gateway stateful inspection architecture. Yep. So the security gateway integrate both network level and application level protection by combining stateful inspection and application intelligence. All inbound traffic is routed through the security gateway as this is the logical place for active defense to reside. System resource and processing time are saved by processing packet in an operating system kernel. Application and processes in a kernel layer suffers little if any performance degradation and can support data throughput rates ranging in multi-gigabits. The security gateway kernel is placed between the NIC and the TCP/IP stack, which solving the problem of protecting the TCP/IP stack itself. Now let's talk about the inspect engine packet flow. Under this, inspect engine packet flow. If the packet pass inspection, the security gateway passes the packet through the TCP/IP stack, and if not, it's not. Packet pass through the network interface card, NIC to the inspection module, and up through the network stack. Some packets are defined destined for operating system local processor. In the case, inspection module inspect the packet and passes them to the TCP/IP stack accordingly. If the packet do not pass the inspection, then they are rejected or dropped and logged accordingly to the rules set in a rule base. The packets are not processed by higher protocol stack layer unless the security gateway verifies they comply with the security packets. To understand this statement, let's draw a small flowchart. Uh, Consider this is the NIC from where the packet is coming. Then there is something called new connection. if the packet is newly come. If that is a new connection, yes, what will happen? If it's no, then what will happen? If it's no, the new connection is not there. Based on your stateful feature, the packet is directly go to the destination. As I have already explained what processing happens in a stateful inspection, so using that the packet is goes to the destination. So I hope this part is clear about the stateful. But if there is a new connection, then what happens? Then first thing is packet its match against the rule, right? If yes, the rule is match, then the log or alert for that rule or for that packet is generated and goes to the SMS for further processing, and the decision for packet allowing or not allowing based on the rule take place here. If yes, then packet, I mean the packet rules is allowing that packet, then it goes to the destination. If not, the rule is not allowing that packet, then what happens? This is the important term which we generally uh, ask to the employee for the checkpoint interview, or we get question for the checkpoint interview. If that packet is not match, what happens? Then if the packet is not match or packet is rejected by the firewall rule, two different statement. One, packet is not matched, there is no rule for that uh, packet connection, then that is ultimately dropped. There is no question on that. But if the rules is dropping that or rejecting that, then what happens? So this is actually the rejecting by rules. Then what happens? That firewall which rejecting that packet is send negative acknowledgement, which we call NAC, negative acknowledgement, to the sender that okay, this is something is we don't allowing. So NAC is sent and the processing for that packet is stopped, right? So this is very important thing. When your rule is rejecting your packet, when your rule is rejecting your packet, then negative acknowledgement is sent and the processing is stopped. If rule do not see that packet matching, then it's ultimately dropping. There is no need to do anything here. Okay, I hope this part is clear. So the next part is your deployment consideration. Deployment consideration. So basically, based on the architecture or the architect what we have in your organization, based on their decision, architect their decision, we design the network. The design is the network designing is done. Architect suggests what product we need to buy for the security, what will be the communication diagrams or the network will have So he will give you high level designs, and then the engineer's roles comes like putting those details into the picture, or you can say the administrator's roles is come into the picture and implementing this part. So the architect is something which is very important in any organization. So if you are very good at the checkpoint firewall, you'll get a role of architect for deployment purpose as well. But you need to learn that part. So basically, deployment comes in a two forms. One is your standard deployment, and the other one is your distributed deployment. Deployment. Let's learn what is in standard deployment first, and then we'll go to the distributed deployment. So, in a standard deployment, you have SMS, security management server, and the security gateway. So, consider this is your checkpoint firewall appliance. Checkpoint appliance. Okay. Within this appliance will be achieve the functionality of your security management server and gateway. This is what we have as a standard deployment. Same goes to the software. If you have a software and you have a soft piece and you are installing into the some sort of servers, so this servers part is divided with the SMS and with the gateway, two part, right? Now what is the drawback having this sort of things? The number one, consider due to you know some situation like the electricity or some admin mistakes, this appliance goes down. During such scenario, at the same time the SMS functionality goes down and gateway functionality goes down, and your packet processing gets stopped and you have a outage, right? Advantage of having this sort of deployment, it saves your cost. Obviously you don't have to purchase a different appliance for a different purpose, so it saves your cost, but in a situation it gives you big loss also. Okay. And the second deployment consideration is distributed deployment. In distributed deployment, you having one SMS box or appliance, security management server, and one your gateway, appliance, piece, soft piece, or the gateway. And this is managed by some PC, say. What is the advantage of having this sort of scenarios or this sort of deployment? Number one, for example, due to some mistakes by the admin or the electricity issue, only the SMS goes down. The SMS functionality gets stopped, but your traffic processing is actually done from the gateway. So that remains. So no outage, right? There is a flexibility that, or this sort of flexibility we will get. When working with this sort of scenarios, I mean, in a networking world, there are a lot of scenarios or things happens. With the application admin itself, we generally do some sort of mistakes. By mistakenly, we do some mistake with the SMS, and we stop processes of the SMS. But it impacts with the SMS only. It don't impact to the gateway because it's a different layer architecture. So this is what we have in distributed deployment. In a distributed deployment, the security gateway and the SMS are installed on a different computers or appliances, as I have just explained. And now this is to standard things. With the deployment itself, we have one more functionality here. I mean, not a functionality, one more scenario how we can deploy these gateways. So we call it as standalone full high availability deployment. So we are not going to talk about the full high availability. We are talking about the high availability in sense of deployment. So in a standard full high availability deployment, the SMS and the security gateways are each installed on one appliance, and the same for second appliance, which works in high availability mode. I'll just show you. So for example, you have a two appliance. Here you have a SMS and gateway in one appliance, and there is another appliance. Here you have SMS and a gateway. Between them there is a HA. So what happens in HA? Traffic is processed by one of the active member. So consider in this scenario, this one is the active and this one is passive. So now the traffic is processing from the active gateway. Due to some issues or electricity issue, if this goes down, the load or the traffic is fail over to the secondary gateway here. So having the same functionality like SMS and the gateway on a same uh, device, but having the high availability in place, we'll be achieving no outage because one appliance is goes down, but the other is going, come up. And although if the one of the functionality goes down from this appliance, say SMS functionality goes down, that will actively fail over to this. So likewise, if the gateway's functionality goes down, it will fail over to this another appliance. So likewise, we get no outage and everything goes well. And now the last part of the deployment consideration is your deployment in bridge mode. So a bridge mode deployment adds a security gateway to an existing environment without changing IP routing. This is the purpose of this bridge mode deployment. For example, you have a already running configuration with your SMS, your gateway, okay, and if you want to install a new gateway for the purpose of monitoring the traffic, doing some sort of basic functionality on that gate, using the another gateway, you can use a bridge mode here, and that bridge mode will give you the functionality where you can add and new security gateway to this existing network without changing any IP address here. So guys, this is what uh, basic things I have covered on this lecture. If you like my video, please subscribe my channel, share my video, and I'm happy to see my subscriber are increasing. Thanks for watching my video. Have a good day. Bye bye.